Chapter 11, Area of Polygons. We're going to start off with 11-1, Area of Parallelograms and Triangles. Before we get started, though, I have a joke for you. What do you call two angles that crash? What do you call two angles that crash? All right, let's go ahead and get started with our notes. So we're going to talk about the area addition postulate. If you like to take notes, you can. It's totally optional. No, I don't want to make it optional. Take it. Chapter 11, Area of Polygons. We're going to start off with 11-1, Area of Parallelograms and Triangles. Before we get started, I have a little joke for you. Maybe you've heard it, maybe you haven't. What do you call two angles that crash? What do you call two angles that crash? All right, let's get started on our lesson. Area addition postulate. That says that the area of a region is the sum of the areas of its non-overlapping parts. Area of a parallelogram. You have learned that before, area of a parallelogram. Area equals the base times the height of the parallelogram. And then let's look at our first example. Find the perimeter and area of this parallelogram right here. Find the area and perimeter. Since opposite sides of a parallelogram are congruent, RS is congruent to UT, and then we say that RU is congruent to ST. So then UT is 32 inches, and ST is 20 inches. So let's find the perimeter. Perimeter is 2 times the length plus 2 times the width. Or you could just add all 4 sides. And your answer is 104 inches. Now let's find the area. The height of the find the height of the parallelogram. The height forms a right triangle with the points ST and with base 12 and a hypotenuse of 20. So we're going to use Pythagorean theorem to find this height right here. So a squared plus 12 squared equals 20 squared. You guys can do all the work, and etc., etc. A equals 16, so that's the height of the solid. And now area is base times height, which is 32 times 16, which is 512 inches squared. I think we're good with that. That is a great example for us to use. Here's the new thing today. Not new, but fun. Let's make it more fun. You may need to use trig functions to find the area of parallelograms. Trig functions, woo! Let's go ahead and start off with the first one. Let's do a 45, 45, 90. So this is our 45, 45, 45, 45, 90 formula. Let's do an example now. Find the area of parallelogram PQRS. So it's a 45, 45, 90 right here because it tells us 45 degrees. First, I need to use 45, 45, 90 to find the height of the parallelogram. So this is 9, this is 9. So this is x, and x radical 2. So x radical 2 equals 9. I want to find this little piece right here. Radical 2, to find the height, my bad. Radical 2. So x equals 9 radical 2. Since I'm going to allow you to use a calculator for this, and we're going to round to the nearest tenth. Okay, you can leave it like this. So now we know that the height is 9 over radical 2. I know, illegal, huh? Which is crazy to look at it like that. Anyway, so now I'm going to find the area, base times height, which is 12 times 9 over radical 2, and that is approximately 76.4 units. Hopefully there are no questions on that. Here's the rule for 30, 60, 90. So there's my example. So we say x is 12, then the height is going to be x radical 3, so we write 12 radical 3. The area of a parallelogram is base times height, which gives you 32 times 12 radical 3. And when you multiply that, you're going to get approximately 665 and 1/10 meters squared. Move on to triangles. Area congruence postulate. If two figures are congruent, then they have the same area. No explanation needed. Area of a triangle. Area is half the base times the height, or base times the height divided by 2. We need to buy enough boards to make the frame of the triangular sandbox shown and enough sand to fill it. If one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need to buy? So the first thing we need to do is find the perimeter of the sandbox. So go ahead and find the perimeter of the sandbox. All right, there's the perimeter. Now find the area of the sandbox. Go ahead and find the area of the sandbox. The area of the sandbox is 54 feet squared. So now we're going to use unit analysis to determine how many of each items are needed. Unit analysis, shout out to science. The boards, the perimeter is 35.5 feet times, and we know that one board is 3 feet long. So one board, 3 feet. The feet cancel, and then I want board, because that's how many I want is boards. So I multiply that, divide by 3, and I get 11.83 boards. But we can't have 11.83 boards, so we're going to go ahead and say that that's 12 boards. Now let's look at the next one. Round the number of boards. Oh, okay, so I did it right there. Bags of sand. Bags of sand. One bag of sand fills 9 square feet of the sandbox, and we know that the area is 54 feet squared, so I have 54 feet squared times one bag of sand. I'm just going to write one bag. 9 feet squared. The squareds cancel. I multiply 54 times 1 divided by 9. My unit is bags, so I have 6 bags. And there you go. Let's continue to the next part of our lesson. Last part of our notes is going to involve using algebra. Here's the first problem. So the height of a triangle is 7 inches more than its base. The area is 60 inches. Find the base and the height. First, let's write an expression to represent each measure. We're going to let B represent the base, and then we're going to let the height equal B plus 7. 7 inches more than the base. Now, we're going to use the formula for the area of a triangle to find B. So area is 60 equals B times B plus 7. All of that divided by 2. Now we're going to use algebra to solve. I'm just going to do 60 times 2 is 120 equals B times B is B squared plus b times 7 is 7b. Looks like we're going to have to factor. So let's subtract 120. I'm going to rewrite the problem over here. B squared plus 7b minus 120 equals 0. Oh, factoring, your favorite from algebra. All right, so I need to find out what factor what factors when I multiply them are going to give me negative 120 and are going to give me a sum of 7. Negative 120 and a sum of 7. Well, we get 8 and 15. Negative 8 times 15 is negative 120. And when I combine those, I get 7. So my factors are negative 8 and 15. So I have b minus 8 times b plus 15. And all of that is equal to 0. So you separate your equations, set them equal to 0 and solve, and you've got b equals 8 and b equals negative 15. We can't have a negative distance, so my answer is 8. Therefore, the height is, which equals 15. And that's your final answer. All right, have fun with this lesson. Oh, the answer to the joke. What do you call two angles that crash? A rectangle. Oh, that's so funny. A rectangle. All right, guys. See y'all in the next lesson, 11-2.